But I think we have a new administration since last year, so we'll see. I mean, at the school. All right, so I started the video. I'm going to maximize. Do you guys have questions before I go on? So mostly there were a few joins in. One query, SubQuery. There were a couple things on joins. It looked to be, some of them looked really good, and there were a couple confused ones. I'm trying to remember where the confusion was. One thing you never want to do, let's just do a quick, I'll say use Community Assist. And I'll run that. Did I run it? There it goes. So one of the things, let's say you wanted to see person and addresses. So I'm going to do like, we'll just do select star. Because I'm not going to run, well, maybe I will. I saw some people do this person address, or an in-person address. What will that do? Anybody know?
But is a person address inside of person? So,
No, it's a separate.
Oh, it is?
It's a separate table. Notice that there are 17,286 rows. There's only 130 people.
Is that cross-join?
It's a cross-join. And I see a lot of people do this, like this is all you have to do to join tables, and it doesn't work. I mean, it does work. It doesn't throw an error. It gives you a cross-join, though, so it gives you every possible combination. So the data is essentially meaningless unless that's what you're looking for. And we got 17,000 rows out of 130 people. You know, if we had 1 million people, you would suddenly have like 1 billion rows. Yeah, actually, you can crash a computer. You can fill RAM. So you should never just list the tables. There isn't a syntax set where you can do this. You could say where person.person key is equal to person address dot person key, and that has the same effect. This is a legitimate inner join. Notice it's only got 134 rows, which is what we should have. I don't encourage, it's good to know that this kind of join exists, but it has some drawbacks. One is it's really easy, especially when you're mixing multiple tables, to get an accidental cross-join, because it won't throw an error if you forget to say how the tables relate. It'll just do a cross-join automatically. So say you were joining 4 or 5 tables and you did the relationship of 4 out of the 5, you still have a cross-join with the 5th. So it's a dangerous syntax that way. You have to be really careful with it. It's more efficient in the sense that it actually takes less words than the inner join, but it's a little bit dangerous. The other thing that they don't like in the theoretical world is you're conflating a relationship with a criteria. Where clause is supposed to be for the criteria of the search. So it is possible to do that, but if you ever just list your tables, you have to say how they relate to each other. With the inner join, that can't happen, because if you say inner join and don't do an on clause that shows the relationship, it'll throw an error. Whereas this syntax won't. This is older. This is how they did inner joins up through the late 90s, early 2000s. And then they came up ANSI people, the standards people came up with the InnerJoin syntax and CrossJoin and OuterJoin. It made them all. It used to be if you wanted an outer join there, which won't make any sense here. Actually, it might. It used to be you could do that. That's the equivalent of a left join, but notice that everything gets red underlined there because it doesn't support that syntax anymore. And a right join in the old syntax would have been an asterisk to this side of that thing. I wonder, this is a good question. Are there any people without addresses? I'll do an outer join, and then what we'll do is the stuff for the day. So outer joins are confusing initially, I think, right? So I am going to, let's do select, I'm just going to do first name, person first name. And I'm going to do PA dot person key. PA is going to stand for person address. So I'm going to say from person. What I'm looking for, and we may get nothing because I'm not sure. I'm looking to see if there are any people that don't have addresses. So we want to list all the things from person. And I'm going to actually it's outer left join. And the outer is optional. And I'm going to, is it left outer join? Let's just do left join. No, that's okay. Person address. And then I'm going to say on with O instead of 0 on P dot person key equals PA dot person key. So what that does is it's going to return all the people, right? No matter whether they have an address or not. But on the address side, which is the right-hand table, it's only going to return the tables that have matching records. So if there are any people that don't have addresses, this person key, which I made it careful to specify it comes for person address, will be blank. It'll be null. Only in the result set. There's no nulls in the actual table. So we'll see if there are any nulls. There is a null. Is that the only null? I only have one person that doesn't have an address. All right. But and to see that more efficiently, I just wanted to show you the pattern. You could say where PA dot person key is null. So we do have one person that doesn't have an address. Does that make sense for the outer join? I just wanted to review it because I think that's one that's harder to get your head around. An outer join, as I said, returns all of the records from one table, but only the matching ones from another. Inner joins only return matching records, right? Records where there's a key and a foreign key. They only return the ones that match. An outer join on one side, left if you're doing the first table, right if you're doing the second table, returns all the records from one side and not from the other. There's also the full join, and we did that. The full join actually has the same result in these cases. But it's possible there could be nulls on both sides if there were addresses that don't have any people associated with them. Again, that would be a sign of bad design, but it could happen. All right, so these are, I'm just going to joins leftovers. The topic for today is actually what they call table expressions and views. Any idea what a table expression is? It's really just a continuation of subqueries. Table expressions are where the subquery is in the from clause. We did them in the select clause. We did them in the where clause. These are subqueries in the from clause. So basically, you're querying a query. Does that make sense? They can be really useful for some things. That being said, the examples I'm going to give you aren't that useful, but they can be really useful to study. So I am going to do one. I'm going to just do select. I guess I'm going to select person last name. Well, let's just we'll alias it a little. I'm going to do select last name, first name, city, and then I'm going to do from, and then I'm going to start a second query. I'm going to do select person last name, person first name, and actually in order for this to work I need to alias these, so I'm going to do last name. Let's just break this. First name, person address city as city. All right, from person p inner join person address pa on p dot person key equals pa dot person key, and then we need to close that and say, oh, and I'm going to do one other thing there. I'm going to say where city person address city equals Bellevue, and then I'll close that. I'm going to call it Bellevue residence, and I think as I don't think it's required, but I'm going to do as there because I'm aliasing the subquery. So we've got this long subquery where we're basically doing the inner join in the subquery. And in this outer query, we are actually querying this query. And in order to query this query, we need to use the aliases that we've given. As I said, these aren't super useful examples. And I'm going to break this line because I think it makes it make more sense. I'm going to indent all of this. I'm only doing this for prettiness and to make it clearer what's going on. Okay, so this is the subquery. What is it not like? Inner join PA. Oh, I don't have the and. I lost my and, my on. What did I do with it? Did I just delete it? Got my cap locks on. All right, so when I run this, it gives me the people that live in Bellevue, their last name, first name, and city, and it gives us the aliases. So I said this can be really useful. This instance, this example is not necessarily that useful, but these can be useful. Essentially, you're querying a query. So you can do a lot of work. You know, if you want to do things in stages, you can query a query. This could actually, if you really wanted to get bizarre, have another query in its from clause. You know, you could chain queries together. And sometimes if you need to calculate things in steps, that can be a really nice thing to do. Does that make sense? So it's basically just a select from a, from a subquery. I'm going to do one more of those, and then I'm going to show you a preferred way to do them. These are legit, and it'll work in any relational database. But there's another way that's preferred, which I'll show you in just a second, called common table expressions. Questions on that before I go on? Does it make sense, sort of?
What you did makes sense, but why is it called a table expression rather than?
Because this is
a subquery.
Because we're not querying a table, right? We're calling we're querying what they call a table expression. You're basically creating a temp table with your query. Okay. Does that make sense?
The temp table is called value residence.
Yes, and it won't work if you don't alias it. You have to alias it. You have to create this temp table, right, for it to query.
Okay.
I'm going to do one more of these, and then I'll show you the other, and I'll explain why it's better. They do exactly the same thing. So I'm going to do exactly the same query in a slightly different way in just a moment. So I'm going to, this one I'm going to do, I'm going to basically, let's do, well, I guess I'll do grant type name. I'm trying to think of how I want to do this. I kind of want to alias that. Count. I think types is a key word. I should look at this because I could do this count I could do inside. Let's maybe do it inside. Let's do it this way. Grant type name, total grants. Let's just do the count. Let's just keep it real simple. So I'm going to do from, and then inside of the subquery, I will do select grant type name. I'll just leave that the way it is. I'm going to do count grant types. Grant type key, rather. And we'll call that total grants. And I'm going to do this from. So we need to do it. It doesn't matter which one I do first. So I'm going to do it from grant request. And I'll alias that InnerJoin grant type on GT or whatever. Yeah, GT.grantType key equals gr.grantType key. So I told you we're going to be doing joins like from now on. So there will be lots of joins. And then I have to group by, right? I have to group by grant type name. Why is grant type key unhappy? Oh, it's ambiguous. So let's just do, I want to do it by gr dot. All right, and that'll be our subquery as, what do we want to name it? Anybody have a good name for this? As I'm going to call it as grant count because we're counting, right? Notice that the red lines went away once I aliased it. And if I do this, again, it will give me the total count for each of the grant types. We did this in a simple join, right? So I'm not sure there's a huge advantage to doing it this way, but you can. So we're basically querying a query. And again, you could do this, either of these examples probably could be done else otherwise without way easier. Does that make sense though as a structure? Okay, once we've done that, I'm going to show you the other kind of structures. So these are called table expressions, but what we're going to do next is called common table expressions. Two dashes. Or CTEs. All right, so it's going to be exactly the same. I'm going to do exactly the same query, but I'm going to do them a little bit differently. And this is actually the preferred way. And I'll explain the reasons after we do it. So let's do the first one again. I am going to say with. We haven't seen the keyword with, especially not spelled that way. So with, and we want Bellevue residents. As, I'm going to open and close a parentheses. And then actually I'm just going to copy all of this stuff. We could retype it if you want. So it's going to be between the parentheses. And then down below this, I'm going to do select last name, first name, city. And I still have to this time say from Bellevue residents. This will have exactly the same result as the other. It's a little wordier. So this is called a table expression. They always begin with a with, where you define the table, and then you say as. You have your parentheses in which you have your subquery, basically, and then you have your select from that table afterwards. The reasons why this is preferred is that you are defining your temporary table before you're querying from it, whereas in the other form, you're querying from the table before you've defined it. All right, does that make sense? So up here, you're querying last name, first name, city, but those things don't exist until you define what the table is. It makes more sense logically to define the table first, and then query from it. So this has exactly the same result as the other. It's a little bit wordier, but it does have the advantage that the temporary table is defined before you query it. That's the difference. That's really the only difference between them.
But either way, the word between parentheses, that they will be executed first. But this one is just to make it easier to read it.
It's easier to read. It's a little bit more logical on the page. But yeah, the subquery will be executed first, and then the external character. Either way. Either way. Because it has to, and this is actually true of all SQL. It executes the from clause first. and then it actually goes and looks for the criteria, and then it looks for the fields that it's going to do. I mean, it doesn't execute in the order that you like it. Sometimes that has effects, like when you alias something. Like when we aliased up here, it didn't know which. I had to alias this even though I haven't actually physically aliased it till down here. In C# or Python or something, that would never happen because it wouldn't know what this is because it hasn't got down here yet. But it actually does the froms first. And so when you get up here, because you've aliased it, it doesn't know what grant request is if you were to write it out. It only knows the alias. And it's partially because it's not processing it top down like you would in a normal procedural language. It's doing the from first. And it actually creates a cross join between these and then eliminates the ones that don't relate. I mean, it's amazingly inefficient process for something that results fairly quick answers. All right. So let's do that other one as a subquery. And then we're going to do a couple variations of these, and then table function and some views. The chapter in the book that I no longer possess, covers all these things in one chapter. So the second one is going to be total grants, and it's going to be just like the other one with total grants as, and then you do the parentheses, and then in the parentheses we can go up and get the subquery. I called it grant count. Maybe I should call it grant count again. So I'll call it grant count. I'm going to change the name up here. Okay, and then when we're down here, we would do select. So we want grant type name, total grants, and we just say from grant count. Now, why is there, may work despite that. Yeah, it works just fine. What was it? Control Shift R? Yeah.
Yeah.
Although sometimes there are things that we're going to do where it just won't recognize them. It's weird that it recognized with Bellevue residents though. And it runs this. So despite the errors, it is perfectly happy with that. Yeah, I don't know why it's not on mine. One lesson about SQL Server and IntelliSense is that the IntelliSense is often out of step. Things that are marked as errors are not always errors. And I'm not sure if I go up, was it under View? Edit. IntelliSense. Refresh local cache. Still isn't fixing that. So I have no idea why. But it works just fine. I'm going to do one other little thing with a table. We're going to make with the city one, but we're going to do it a little bit differently. And this becomes important later. But I am going to declare a variable, and I'm going to declare it at city, and I'm going to give it a in varchar 255. Now, at least in SQL Server, I've been playing with Postgres, and in Postgres you can add an at or not. But in SQL Server, all variables have an at, start with an at. Kind of like in PHP, they all start with a constant, is that right, or $? Pound sign, I think, is Perl. But anyway, it marks it as a variable. We can give it a value. So I'm going to do set at city equals, let's just do Kent. Okay. So, and then I'm going to just bring down the Bellevue one, but I'm going to change it a little bit. Probably should just retype it, but so I'm going to change it to, let's just call it as residence. And instead of doing at Bellevue here, I'm going to put in the variable at city, and then we're just going to say from residence. And I think one of these requires a semicolon, and it might be right here. This is one of the weird instances where it actually requires a semicolon, I believe. All right, so we've declared a variable, and we set a value. This can be really useful for some things, like we're not going to be doing this, but when you're importing a file, you can put the path name to the file in a variable, and then you can just insert the variable. Right? It can be a really nice thing. There's a lot about when we do stored procedures and triggers, we're going to, and functions, we'll be using variables. So they're fairly useful. Now, they don't last. Like having set it and declared it here in a, in a programming language, then they would have their value for as long as they're in scope. Here, you have to run them with the other thing, or it won't recognize them. They have no persistence. Does that make sense? So when I run that, notice it gives me the people that live in Kent. If I want to change that, I don't remember all the cities that I have. There might be. There's a lot. Most people are Seattle. I don't know that will work. Let's see. Nobody's in Tukwila. That's somewhat true. I know we got Bellevue. Nobody in Renton. What cities do I have in there? Well, I could show you. If we do Seattle, we'll get lots of people. But that's, I mean, you can change the variable and just run it, right? So it makes it a bit flexible in terms of what you're looking for.
And it will be useful for web application or
right, and we're going to do, like when we do store procedures and things, one of the things we'll do is we'll create a store procedure. We'll have a list of variables at the beginning, parameters. Those get mapped directly from like a web form, right? So each text box in a web form will map to a parameter in the store procedure. And it's much safer to do that than it is to write directly to the data tables. Okay, so that's the only one variation of this I wanted to show. Questions about that before we go on? So that's a common table expression of a variable. The next thing is a little bit weirder, but it's kind of fun. We're going to do essentially the same thing, but we're going to make it into a table function. So we haven't done a function yet, but we're going to be doing a few. Table valued functions are functions that return a table. They return a whole table rather than a single value. And again, in the book, they're in this chapter because they're essentially another form of SubQuery in the from class. But I'm going to do create function. I'm going to I guess I'll just call it city. It's going to take a parameter of city, and we have to give it a type in varchar. If you actually do varchar, it'll fail, but it has to be not nar varchar, but in varchar. Because in terms of SQL Server, varchar and in varchar are incompatible. One is ASCII and one is Unicode. And you need to give it a size or you'll get a 0 response. And then I'm going to say that it returns a table. See if I'm doing this right. As it's been a while since I've done one of these, so let's see. And basically, the query I'm going to give it is this. Oh, as table, as return, and then I'm going to paste in that query. Now, this should be returns. Did I not do returns? There it goes. I think that's good. The go up here is because it has to be in its own batch. Notice how it underlines the first line. Go separates batches in SQL Server, not in any other SQL. By separating batches, it basically means execute everything before this before you execute anything after it. It means basically clear it. Like if you do create database and then you do create table, it'll throw an error if you don't put go between it because it'll try to create the table before it's done creating the database. Right? So, but if you put a go between them, it finishes creating the database before it creates the table. So it's basically a stop sign. Stop, finish everything before you move forward. Again, that's SQL Server only. Most other environments deal with that by semicolons. But this, except in that rare case up above, you don't necessarily need it. So we're creating a function. We're going to create functions later that return just a single value. We have, you can name it whatever you want. I tend to name my functions with an fx, just to say that they're a function. You can have however many parameters you need. Parameters are what you pass into a function. Like if you were to do a square root function, you could pass in a number and it would take the square root of it, but you would pass in a number, right? So we're passing in a C. This one returns a table, and that's why it's in this chapter about table expressions, because it actually is going to return a whole table. And our table is going to be exactly like what we did in the thing. So I'm going to run this. It's actually, all it's going to say is that it executed successfully. And what that, I'll show you because it will have to use the function. I'm going to zoom up here just to show where the functions are. Might have to go up another one for this one. So when I look under databases, and I look under Community Assist, there's an area called Programmability. And if I go under Programmability, there are functions. And under the functions, there are table-valued functions, scalar, aggregate, and system. So I'm going to click under Table, and you'll see there DBO FX City. DBO is the owner. Database owner is the owner. Later, we'll talk about schema. But the DBO is the schema. The database owner is the database owner. It could be somebody else. You could create different schema and have different owners. But this one is owned by the database owner. And FX City. Also useful if you have this environment is if you need to know what parameters that it takes. If I open that up, It lists the parameters, and the parameter is going to be city.
So I know it's probably getting ahead, but what would having a different owner do to this if it wasn't database owner?
So if you're a database owner, you can run anything, even if it had a different owner. If you put it under a different owner and you log in under that schema, then you can only see and run the stuff in that schema. So if you made a human resources schema and then you made a function in the human resources schema, if you logged in as a human resources schema, you could run that function, but you couldn't run any DBO functions, but you won't even see them. Right? You only see what belongs to the schema and you belong to.
Okay.
And DBO is the owner of all schemas as well as everything else. So just as a side note, we are logging in as admin and as database owner. In real life, that's not a smart thing. You should create a secondary account that has good privileges, but not DBO privileges, not admin privileges. And you should only log in as admin when you actually need to. Because you can do a lot of damage accidentally as a database owner. And this is true of databases in general. I didn't do this because it just adds another level of complexity getting started. Right, but there should be, you should probably log in under a lesser account than you.
Even if you are the person who has access to
Yeah,
that,
even if you are the
should
person, you should log in
limit
with a
yourself.
lesser account unless you need those specific permissions. Because you don't want to, particularly say it's late at night, which with a database administrator could be the case. 3 in the morning, you went out and had a few beers with friends, but you have an alert that you have to check something. You go in as database owner, accidentally type something and destroy the database. Which wouldn't, a little bit later, I'm going to show you, not today, but we will show you some things that could destroy a database fairly easily. They're fairly normal commands. It doesn't even ask you, are you sure? Just executes what you say. So that's why, anyway. But that's where the table valued functions are. Aggregate functions, well, we'll do scalar value functions. Those are ones that return a single value. Aggregate functions actually are not doable in SQL and SQL Server. You have to write them in C# or some other language, and we're not going to do that, but aggregate functions are hard. Interestingly, I've been playing Postgres. Postgres has ways that you can write aggregate functions in their modified SQL, what they call PG SQL. Writing functions and stuff is actually, this is like intermediate stuff, I think, at least. But it's good to know. If you're working for somebody running queries, you're not likely to create functions. But they can be really useful for a database because you can do things that, rather than have to calculate them each time or something, you can create functions that'll do those things for you. The only functions that are in here, and I'm just chatting now, but not under aggregate, not under system functions, those are the built-in ones. Scalar, I'm missing everything but the scalar. There are 2 functions in here. There's get seed and hash password. So I wrote functions to hash the passwords into seeds. We'll look at those later. All right, so we wrote this function, but how do you use it? So let me zoom down. So to use this function, actually you just put it in a select. But this is different than other functions where usually they are in the select. But I'm just going to do select star from, and then I'm going to do dbo.fxcity, which is in my IntelliSense. And then I need to provide a city. So I will provide Kent. Okay. Now, when you're using a function, whatever kind of function, if it's one, you have to include the schema. You have to include DBO dot, or if it's something else, whatever that is, dot. And I'm going to just run that, because essentially it's again in the from clause. And there it goes, there's Kent. And if we did Bellevue, it would work. So we have a little function. And if you needed to find out what people, from a large database, what people were from a particular city, this would be a real quick way to do it as opposed to writing the query every time. So if I do Bellevue, and you could do more complex queries too, right? So you could probably like enter a year. So if you wanted to, you could enter a year and do like a summary report from that year. There are things you could do. Yeah.
Mine worked without the schema.
Did it? Shouldn't. Let's see if it works with mine without the schema. Maybe it will, because we're in DBO, maybe. Yeah, it worked. Shouldn't. They usually throw an error, but maybe table value functions don't matter as much as the scalar ones. Or maybe they've changed that in 2017. Because I've done it, I think this is the first year I've used the 2017 model. It's always been like the 2014 one that we were using before, the 2012. That's good. I mean, that saves you a little bit of extra research there. All right, so notice that this has a red line under it again, because it wants to go before and after. Again, it doesn't matter. It'll run just fine, but if you don't like red lines, you can get rid of it by putting a go after it. So this is the last thing we're going to cover, and there's some variations of these, but we're going to talk about views. You guys know what a view is? No? So a view is basically a way of looking at the database. When you're designing views, usually you think about who's using the database and what view of the data do they need to see. It's a stored query, right? So once you've created a view, you never have to write that query in. So let's do, I'll do a complicated one. I'm trying to think of what views I've done in the past. I'm going to create view, and then we need to give it a name, and I often do a VW. I'm just going to say annual report, and I'm going to do as. Here the as's are not optional. Kind of like up above here when we did the function, there's a returns table as. It's still the idea of an alias, but basically VW annual report is an alias for everything that follows. Does that make sense? And the function is an alias for everything that follows. But these as's are not optional. So I'm just going to do select. Basically, I'm going to grant type name. So I said annual, right? So let's don't do grant type name. Let's do year grant request date. And you have to alias these. If you have a function, this doesn't allow an unaliased function. And then I'm going to do some grant request amount. So I have to alias that. I'll call it total. And then I'm going to do average grant request. And I'll do that as average because average isn't a reserved word. And these all can come from grant request. All right. So, and this has that because it wants a go. A lot of the create things want goes. So if I run this, oh, I have to group by year. It'll fail if I don't group by year. So if I run that, including the group by, my mouse is just floating here. So it says it completed successfully, right? Kind of like the function. So I'll show you where it went. And what I'll do is, so notice that there's a folder here called views. And if I open that up, there's the annual report. Now there are built-in views. When you look at the system views, there are hundreds of them, literally. But this is our view, one we created. Yeah.
So sorry, you labeled it annual report in line 93.
Yeah.
And then the 94 as, is that for the stuff below or the stuff above?
So it's all one thing. So we're creating a view, and then this is the definition of the view. Okay. All of this is defining the view. So you have to run it all together, and it creates this object called a view. And you know, it'll show you that it has things like columns. You can see what columns are in it, and etc. Now to use the view, you just use it like a table. So if I say select star from VW annual report, it gives me the year, the total, and the average. And you could do some things in the view too, like we could format it a little if we want. So if I want to, I'm going to format, and I'll make this into money. 1, 2, 3. You don't have to do this, but if you wanted to make it prettier. I need to close that paren. All right, and then the other thing that you would need to do is you can only create once. Afterwards, it's alter. So if I were to run it again with the alter, oh, I still didn't get my parentheses in there. Why did it not go in there? All right. So I'm going to alter it. And when you alter it, you run the whole thing and it'll change it. Now when I run it, it has it with the dollar signs. And you can do things too, like if you just wanted to see 2015, you could say where year equals 2015. All right, so you can do froms on it and etc. You could have done a from in it if you wanted a separate view for each year. You can't do order by. Weirdly, order by is forbidden in views. Couple of things about this. Views, again, are real. So if you were an administrator and you wanted to see this, it's all prepared for you. You just call up the view. And it would have, and it's not, there's no data in a view. It's just a filter. So anything that comes through is live data. Does that make sense? So in 2019, if you had data for that, the 2019 data will come through as well. It's not storing any data. It's just a filter. The other thing about it for security is I did select star, but say I wanted to select grant request date from this view, what would happen? So I'm going to say select grant request date. There's really no fields here, but you can't, the thing is you can't see the underlying fields through the view. You can only see the aliases. So here it came out as year total average. So if you said select year, just to make it so it's grant request date from VW annual report. It will fail. Let me clear that parentheses, although that shouldn't matter. It says no such column. One of the things you can use views for as an administrator is to hide the structure of your database. You give them the information that they need, but they don't need to know what tables it comes from. They don't need to know what the underlying column names are. All they know is what the view exposes for. Does that make sense? Some views you can update through. We haven't talked to that. Some views you cannot. This one you couldn't update. In order to do an insert or update to a view, it has to go to one table. It has to have no functions in it. There's a lot of things. We'll talk about store procedures later. Store procedures are a better way to do that kind of thing. Views are really about just giving people the data they need. Yeah.
In line 96 and 97,
yeah.
Before you formatted it, did it say select or was it just sum?
It was just sum. There's only one select.
Okay, in that purchase.
Yeah.
I just want to make sure it's
yeah, it's not subqueries. We're just doing so the format is optional, but it makes it so it comes out as dollar signs.
Right.
But I just did a sum and an average. What you have in a view is up to whatever you think the people need to see, what the management needs to see. Let's do one for employee, and I'm going to show one other feature of it. And then I think we're done with these. So other questions before I go on?
I don't know why exactly, but if you don't have the square brackets around the year on all this stuff, it still works.
It works just fine. It does, but it does put it as fuchsia or whatever color it is.
It does change the color.
It works fine because it actually goes by context, and so because of the fact that it's in the in the where clause or things, it will figure out that it's not a function in this instance. Most of the time, not always.
It's just better.
Yeah, it's just better, yeah. The ideal thing is not to name things the same thing as functions, but that's hard because there are thousands of functions, and they cover a lot of the normal things you want to name things. Like grant, you might notice is a reserved word. We'll use it later. Percent is a reserved word. There are lots of reserved words. All right, so I'm going to make a second view, and I'm going to add one thing to it. But first, we'll do the view first, and then we'll alter it. This one, let's say create view You can name them whatever you want. I'm going to call this one employees. Couple of things. Although you can name them what you want, it is always dangerous to name two things the same. You don't want a view named the same as a table. Does that make sense? So I'm going to do as. And what I'm going to do is I'm just going to give us, like select first, person first name. And I'll alias it as first name. I'm not being careful about caps, but person last name. And I'm going to alias it as last name. Person email. And we'll just do that as email. Since I'm doing all lowercase, I might as well stick. And then I'm going to from employee. So I'm going to open up employee. I just need to see what the fields are. So let's do, we're going to actually also add person address street. Is that the name of that? I'm going to, I think under person address, I'm just going to give like a view of the basic employee information. So let's do street, city, state. And I will actually just call this street. Actually, state probably wouldn't matter. You assume if they're working there, they live in state. But I will show you that state is a reserved word because things can be in different state in terms of position. So I'll put it in square brackets. And again, context would tell it that it's not being used that way. And then the last thing I'm going to do, these will be from employee. So I'm going to do employee hire date. And I don't think I'm going to put the salary in here, but I'll do employee hire date. And I'll just call that hire date. Okay, so we got to do some joins. From person, and I'll alias that as a P, just for my sake. InnerJoin, we can do it with person address. On P.person key equals PA.person key. And then InnerJoin employee. I'll do that as E. On E.person key equals employee.person key. I mean equals P.person key. So basically we're getting all the information about an employee, right? One of the things I often do just to make sure that this works before I save it as a view is I'll just run the query inside. So those are the employees with their addresses and their hire dates. Do you guys need a minute on that? Again, like InnerJoins only bring back matching. So if you think about it in sets, the first set is all of the people. The second set is all the people with their addresses. But the third set is only the people who are in the employee table. So it reduces them to just those. So I'm going to save this as a view. If I can find my mouse. Why is my mouse floating so much? Come on, up there. So it just says that the command is completed, and it's the same as before. It'll be under views.
Sorry, you saved it.
I ran it.
You ran it.
When you run it, it saves it, and it puts it under views. So if I go down to views,
You have to save screen.
yeah, you don't actually have to save it. If you run it, it exists. So I'm going to right-click on views and refresh, because it won't show it automatically. And then notice it's VW employees is there. So when you run it, when you save it, it just saves the script. When you run it, it actually creates the object. It's now a part of this database until such point as you delete it. Right? It'll be there forever until you delete it. So let me zoom down because it's really big right now. My mouse is just like, it's not tracking that well. Questions on that? I can move this down a little. And then we can run this view, right? So if I run the view, it'll give me the same essential thing. Now, you can't order by in a view. It'll throw an error if you order by, but you can order by the results. So I'm going to do select star from VW employees order by hire date. Employee, actually it's by hire date, because you have to use the fields that it gives you. So ordered by hire date, first, and then so 2005 up to 2013. But if I put that order by in the view, it would complain. I'm going to do one last thing. I'm going to copy this view, and I'm going to alter it. I'm going to add something to it. So I'm going to alter the view. And I'm going to say with schema binding. Any idea what that does? No wild guesses.
I'm going to guess that it changes the new version of the view.
Well, alter does that. It changes it to the new version. But with schema binding does something. You have a view here that's based on, what, 3 underlined tables and fields within those tables. What if somebody, a database administrator or somebody else came in and changed those tables underneath your view? The next time you call up that view, and a lot of times views are what you're displaying on the web page too. You're calling a view to display it. It'll fail because the underlying structure of the tables has changed, and so the view is invalid. What schema binding does is it makes it illegal or forces you can't change the underlying table unless you would delete the view.
Is something wrong with that, or is it because there's no go?
It's because there's no go.
Okay.
So I'm going to alter the table and add the schema binding. If you're going to do the thing I'm going to do, oops, what did I not like? Oh, I have to do the DBO. if you do schema binding, you have to say what version of this. So I have to do dbo.person, dbo.person address. I always forget that. And then dbo.employee. You have to put the schema with it. Part of schema binding, I suspect. So if I run it now with the schema binding in place, with the schema in place, then it succeeded. It did it successfully. If you did not manage to do this with schema binding successfully, don't do what I'm about to do, which I'm going to try to remove the email from the person table. So schema binding makes it so you can't change the underlying tables underneath. So let's say I wanted to, I'll do a go so it doesn't underline. I'm going to alter table person. I'm going to say drop column person email. Now, normally, if you do this, it would just be gone. All right, person email would just be gone. And no recovery. But because of the schema binding, I should get an error. I will be very unhappy if I don't get an error. Okay, so maybe I'll zoom up on that message. It failed because one or more objects. Notice it says object VW employees is dependent on the column person email. And then it also, the object unique email, which is our constraint, is dependent on that column. Alter table drop column personal email failed because one or more objects access this column. As I said, if you didn't have the schema binding, it would be perfectly happy to drop that column. Does that make sense? It's a way of guaranteeing, particularly when you're building applications based on the views, it's a way of guaranteeing that the views are not just arbitrarily changed or dropped.
Couldn't someone just delete the schema binding?
They could, well, they'd have to delete the view, which they could do. That is actually the one way. But then you have to deliberately delete the view. You can't. If your program is, so you have a web page that's calling this view, yes, if you delete the view, that's going to break the program. But at least they have to mentally choose to delete the view. Whereas if you're just messing with the tables underneath it and you weren't aware of what the dependencies were out there on the web applications and things, you could screw them without even knowing it without the table binding thing. So at least at this point, they would come back, if they're trying to change the table, they would say, oh, there's some things that are dependent on it. I should at least maybe talk to the application people before I do these changes. Yeah. Yeah.
So you did the schema binding and you did the alter table.
Yes.
So this is a point of fact, as a point of best practice, would it build a schema? Should you use something about it?
Yes.
When you build it, should you use schema binding?
Yes, you should. I did it just to show the variations there. There's actually a lot of things when we get to talking more about schema and things. One of the typical things, let's see, I want to just lower this. Well, maybe not. We're doing things in terms of just learning the SQL. But when you're actually designing the database thing, you should think about the database tables. You should also, something we're going to talk about later is like adding schema. You know, you should think about what those schema maybe should consist of, because schemas can be used for security. Objects that belong, if you make a person belong to a role and that role belongs to a schema, then they will only be able to see the stuff in that schema. So you could make a series of views and store procedures for human resources. When they log in, they're assigned to that role. That's all they can see. They can't see the financial stuff or whatever. They can only see, you know. So as you're designing the database, you should be thinking about what views you're going to create, what schema, what store procedures. The thing is, you have to kind of know it all before you can do that, right? It's fairly typical, particularly with a database. It's not typical with MySQL, but for SQL Server, even Postgres, it's fairly typical to create like a whole layer of views and store procedures for applications so that they never touch the tables. Because it's dangerous to allow a web page to talk directly to a table. And yet MySQL, that's the model in MySQL generally. But MySQL is used mostly as a kind of a content management for the web. You know, it's not typically used for like financial transactions and things like that. And SQL Server and Postgres are typically used for more enterprise level, and Oracle for that matter. So I just want to unzoom it. I think that's it. Do you guys have questions on that?
I have a random question.
Sure.
If you create, if a database administrator or whatever was creating a table with confidential information like salary perchance, and they created a view for an employee in HR, like a lower level employee to look at something, but then they were like, oh shoot, I never should have had this particular salary information in the table, but I had already created a view for that person to
You can
view.
always alter the view and get rid of it, or
Right.
you can.
But if that person were to have deleted the information from the table, would it still be in the view that?
No.
No.
But typically, you probably want to keep that information. But in the view, one of the things in the view is you don't have to let them see all the columns in the table.
Right.
So
But they
you
accidentally did it.
Yeah, well, so you could just remove it from the view and they couldn't see it in the table anymore. Typically, one of the things you can do for users is you can give them permissions to access views, but not give them permission to access tables. Right? So when we do permissions and roles and things like that, I mean, you don't have to. You can give people permission to see the views and deny them permission to look at the tables. So their only view of the database is what's in the views. I think in other classes I mentioned one of the ways to do privacy is to separate the table into a public table and a private table, but you don't have to do that because you can create views on that table. One for the public information, you know, and the other more private for just human resources uses. And then you can give different permissions so that presumably you won't be able to get to the private information unless you have the right logins. So views are really useful. So are store procedures, which we'll do later. But views are basically ways of looking at the data, ways of controlling how you look at the data. And a hard thing to think about when you're first designing was what views. You have to think about who's going to be using the database and what views of the data do they need. Right? And then the store procedures is more what kind of ways are they going to have to manipulate the data. So for like inserts and updates and deletions and things like that. Okay. Other questions on this? This is actually a lot, but if you think about them, they're all just basically ways of doing, you know, creating tables out of queries. So a view is basically a saved query that acts as if it were a table. The you know, the table expressions is just you're creating a subquery in the from clause. It's kind of like what you're doing in a view, except it's much more temporary. The table expressions are essentially the same thing, it's just a little bit more logically laid out. Table expressions can be really useful, again, for the same reason subqueries, the subqueries and from can. And that you can sometimes do, if you have to do intense calculations, sometimes you can do calculations in the subquery and then calculations based on the calculations in the outer query. Does that make sense? It can be really useful that way. I'm going to copy all of these. I still don't know why that one's red. Okay. All right, so I'll paste all this. There is a video of it. I think these are harder in concept than in practice. They're not hard to do. But no other questions? So you have about a half hour to work. I will also give you Wednesday to work on this. So I want to kill the video before it has too much dead space on it.